Hi, this is Concept Based. I'm John Hepworth. How is the start of Year 11 Advanced going, students? Is it moving quickly? Like I said, it probably would. You'll find that, as I mentioned, you will go through the algebra very, very fast. I'm even going to be skipping some dot points out of the syllabus in my videos to make sure that we can get through all of the challenging parts of working with functions. So I won't cover every dot point in algebraic techniques. There's a whole section where it talks about expand, factorize, and simplify algebraic expressions where I'm just not going there. Just want to touch on the stuff where I find that students sometimes have challenges from conceptual misunderstandings. So this one today, we've got to rationalize the denominator question here. And I just want to, as always, draw a link back into your Stage 5 Year 10 content. This was in Indices Part C, the path content. And back in there, you learnt about fractional indices and surds for the first time. And you even did something very similar to this. You rationalized the denominator, but you were restricted down to expressions that were in the following form. You may have had to rationalize something that looked like this. And when you rationalize something like this, you came to the understanding that if I can make the denominator just be a rational whole number, then I've rationalized this expression, this fraction. And the way that you've done that is that you've realized that to multiply a surd by itself, we'll end up getting rid of the square root symbol. So you would have gone ahead and said, multiply this by root 5 over root 5. And that would have given us a top value of 2 root 15 over a bottom value of 4 times 5, which we would have further simplified to root 15 over, we cancel the 4 down to a 2, 2 5s are 10, and we would have simplified our surd in the Year 10 course. Now, the step that we're taking up into this question in Year 11 Advanced, it's not huge, but it brings in some other parts of algebra to consider. What I first of all want to just make sure is that the concepts, as always, the concepts are really solid for you, that you really do understand exactly why we are doing this and why it works. Why does root 5 times root 5 equal 5? So just make sure that that is absolutely solid in your understanding. You're not saying your answer to that question isn't because my teacher told me it is. You understand why the square root of 5 times the square root of 5 is 5. And even more so, I mentioned fractional indices there from back in Year 10. Hopefully you'd be able to do this whole question where everything's just expressed in a fractional indice, that you understand that root 5 could be expressed as 5 to the power of a half. So if you're struggling with any of those sort of concepts, root 5 times root 5, or why root 5 is 5 to the power of a half, I would highly recommend doing some revision from your Year 10 textbook in the surds section, just to try and make sure that you are completely up to speed with your understanding of surds before you go ahead and attack a question like this out of the advanced course, where the understanding of those concepts has to be solid, because now we're going to mix it together with some other concepts that come forward in this question. Some other concepts that come forward in this question are really interesting, and I love the way that we actually can mathematically simplify or rationalize the denominator in this surd, because it uses almost what I would consider a trick. Back in the Year 10 course, you did factorizations, and one of the special factorizations that you did was you did this factorization. You said a squared minus b squared, and you went ahead and factorized that, and you said that that is the same as a minus b, a plus b. Okay, so we've got this factorization tool that we've used previously, and we've previously just used it to factorize things. So if that's the case, then we can use it in a weird and different way in this type of question. Why would we be using this factorization in this question? Well, just before in the example that I gave, we wanted to multiply root 5 by root 5 to make root 5 become a whole number and become 5. Well, in this factorization, look, all we've got terms that are all squared. So in terms of surds, if we square the surd, it's no longer a surd. And that's what we're trying to do in this question, is to remove the surds. So this factorization that we had before sort of gives us an opportunity where every term was originally a squared term. So if we did this backwards, right? So if we do this as an expansion of a minus b times a plus b, then we get back to a squared minus b squared. Well, that's very advantageous, because if we can have everything squared, then our surds will disappear, as I mentioned. So what we want to do to try and get back to this a squared minus b squared is we want to create this situation. We want to create a minus b times a plus b in the question, and that will give us some squared terms. So let's go up and look at the question and see if we can create this. In the denominator, we've got root 5 minus root 3. So that's got a minus in it. So the expression that we need has to have the plus in it to make that factorization. So we need to be multiplying this denominator by root 5 plus root 3. So that creates the situation where we have the difference of two squares expansion. We know what the solution will be to that part because we've done this factorization and this type of expansion many times. Now, here we're dealing with a fraction and we've just multiplied by something. We're not allowed to just multiply by things and change them, but we are allowed to multiply by something very special that doesn't really change anything. And what we're allowed to multiply by is 1. Doesn't change anything in terms of numbers. 5 times 1 is 5. Doesn't change anything in terms of fractions. A half times 1 is a half. So as long as we multiply by 1, then we are not changing anything. But what we've multiplied by is a very special one. It's the special one that's going to go ahead and rationalize that denominator for us. So I'm going to look now at the denominator. I'm just going to take it separately just to show you exactly what it is that we've done and achieved here. So we've got root 5 minus root 3 essentially as one term. Now I've put that in brackets, and that's completely okay, because in the fraction, that bar in the middle, which is my favorite word in mathematics, the vinculum in there is actually grouping those terms together. So by having that bar there, it's saying, hey, root 5 minus root 3 is together. It's a thing. And over here in our multiplication, we've got the other part of it in the denominator. Now again, just going back to basics, when you multiply fractions, you times numerators and you times denominators. So I'm just looking at the timesing of the denominator part here. So here you can see we've got the form a minus b, a plus b, which is what we wanted, because we said earlier that if we have that, that's going to create a squared minus b squared. So now when we expand this term, this above here, now I could go and expand the whole thing and do FOIL, which you might start off the first time by doing FOIL, and you would realize that the middle term would disappear, but you hopefully realized that back in year 10. Again, if you didn't, go and have a look at some work out of your year 10 textbook, and it'll show you how this middle term disappears and we just end up with a difference of two squares. So now we're going to end up with root 5 squared minus root 3 squared. And we know that from earlier, where I did the easier example, root 5 times root 5 will just be 5, and root 3 times root 3 will just be 3. And so we're going to get in the denominator 5 minus 3. Now, students will make a mistake here. So Mr. Hepworth, you've written a minus in between there. It needs to be a plus. No, it doesn't. That minus is not affected by the squared. The squared is only affecting that root 3. It's only affecting that second term. It's not affecting the bit in front of it. That's a terrible root 3 squared, isn't it? There we go. That's a little bit better. Okay, so then we go down to 5 minus 3, and then we go down to 2. So 2 is a rational number, right? And so we've rationalized the denominator here, as opposed to having root 3 in the base, which is irrational. Root 5 is also irrational. So we've made it a 2. So that's the whole goal of this trick that we're using to multiply the denominator by what's called It's conjugate. Okay, now that terminology is used in your syllabus, the word conjugate. So if that word pops up, the word is stated here and says, I will directly quote, identify the conjugate of root A plus or minus root B. So the conjugate essentially is just the same as the original expression, but it has an opposite sign in the middle. So we had in the first one minus, and we had to choose a plus to create this. But in the first one, if we would have had a plus, then we would have already had this bit and we would have needed this bit over here. So we would have had to create a minus in the back. So it's always the opposite of whatever it is in the question. That's the conjugate that you're after. So let's go ahead and do this question, or let's move forward with this question. We know that at the bottom of this fraction now is going to be a 2. But what about at the top? We've multiplied by this special conjugate of the base, and now we're multiplying the top, which doesn't have a root 5 in it or a root 2 in it. So what happens now? Okay, well, let's now go and look at the top. Root 3 minus root 2 times root 5 plus root 3. Now, if we go back into our ideas of all the special forms of factorization and expansion that we did in Year 10, this doesn't fit any of them. It's just a standard expansion. So we just have to know how to do our FOIL rule, and hopefully everyone knows that's first outside, inside last. And then we can just expand. So now we've got root 3 times root 5. Now here's a third rule that's popping up. Root 3 times root 5 is root 15. Now, is that something that you remember from Year 10, why that is true? If not, go back to have a look at some of your Year 10 content. It is true. The power is the same for both of them, therefore the bases can go together. But again, you can look at that back in your Year 10 content. So we've got root 15 and then root 3 times root 3. So we have plus 3. And then negative root 2 times root 5, so negative root 10. And negative root 2 times positive root 3, so negative root 6. Now you can see that there's nothing here that is like. And you need to also remember that when you're dealing with surds, we can only deal with like terms. Now sometimes terms that are like will appear. They'll appear because you can simplify a surd, and then you'll end up with the same number inside the surd. Now we can't simplify 6 because its roots are only 6, 1, 2, and 3. Sorry, it's factors. 10 is 10, 1, 5, and 2, all not square numbers. And 15 is 5 and 3 and 15 and 1, all not square numbers. So we actually can't tidy any of that up. And that's just going to stay the same in the numerator for us. We don't have to write it in any order, but I do always write it with the whole number at the back. Why? No mathematical reason. I just feel comfortable with it because I'm used to writing constants at the back of polynomials or functions. So I just always write the constant at the back there. And there we go. We've now got ourselves this fraction with a rational denominator in terms of having a 2 on the base there. And that's our solution. So there's a couple of times during this solution where I said you could refer back to your Year 10, you could refer back to your Year 10. If you're the student that is having to do that and is having to go back over the rules, then look, I really would encourage you to try and think to yourself, you know, what was it I was doing in Year 10 that made me not retain these rules? I would suggest that you were thinking of them as procedures and you weren't really understanding why a particular rule works. In mathematics, if we understand why a rule works, then we tend to never forget it because it's just the method that it's the only method that makes sense because it's what works. Whereas if we're just remembering a rule, there's thousands of rules that we would have to remember. You've got all different subjects that you're trying to do. Some of you may be doing chemistry and physics and so on, or maybe you're doing a history topic where everything is memory, recalling memory of events and so forth. So it's very, very challenging to just remember everything. We really want to know why it works. Then we don't have to remember what the rule is. We just understand what that concept is. Again, if you're looking for some help in relation to some of this Year 10 content while you're doing Year 11, or if you want some help having these concepts explained this way as a concept, not as a procedure, then reach out, concept-based.com.au, and yeah, we can tee up some tutoring and help you out going down this path.